Yeah.
Hello viewers, welcome to the second part of this tutorial. This video is a clinic design, it's a hospital main design. So in the last lecture I show you how you can check your drawing. You can check whether the ground floor and the up floor are the same by changing their colors, and how you can insert your columns, put your columns and grids in layers, and prepare your GA just like this, GA placement of your columns just like this, and how you can save your drawing as a DXF so that it will be recognized in Prota structure. So in this lecture we are going to see how we can model in good Prota structure and model this building. So I already launched my Prota structure 2022. You see this is a registered version. I think it is registered and everything is working well. The Prota steel aspect is working well, and likewise the concrete. So in case you need this Prota structure 2022, it's perfectly working, both the Prota steel and the Prota details and for the normal Prota structure. Then you chat me for it. And as we're here, the next thing we do now is to import our drawing. So you can either import it through external reference drawing, or you can go to DXF. The IFC format is in case if you want to move a file from Revit, and there's a Revit IFC, you can save a file from Revit or from SAP 2000 or from Star Pro. You can save it in the format of IFC, then you can import it here to your Prota structure. So the method I'm going to use, we can see safe import. You can use save a file from save, and you can see import it here to continue your design. What I am using is the external reference drawing, which I will click on it. So you add, and then you check the location of your DXF. Now it's on desktop under a file called DXF. So I'm going to check this clinic structure, and I will open it. Just give it time. You will see it will bring some boxes here for it to tick. It's ready. Just give it time. Okay, see, active, make it active by ticking this box. Make it have a 3D, ticking this, and let's use a DXF color, the color that we use in DXF. Okay. And the unit is already in millimeter, it's good. Then we click on import. So as you now click all this thing, we import it. So you still give it time to import. Okay, let's import. Okay, I think that's imported. Now you close, you say okay, and here you can see your drawing just the way it was. So at this point you can, if you don't like the columns that are already here, you can modify, you can remove, you can add. Okay, so now we'll check this pan. to modeling. Let me use grid to know the distance. The distance between this grid to this 5.5 meter, and see the length is 5.4, which is wide. 5.4, which is wide. So let me introduce a column here based on the principle I already told you, that your column to column distance should not be more than 5 meters. So you can properties, okay, column, then we can have a column place here. Have a column place here. Then we can change the position of this column. And change it. This column was supposed to be here. This is on the ground floor, and the veranda on the ground floor is 1 meter. While the passage from here to here, the passage on the first floor is 1.2 meter. So we're putting our column here. So you start exactly at this veranda and go up. So move this column. Let's use the option move. So we can place it here. Okay. Okay. Now this is what you have. Or what we can do, we can remove this, get rid of this column, we can move it. Let's move this column and place it here. So let our columns just be one. Then from all here we have like a cantilever. So let's get rid of this column. Get rid of this column. So the whole of this is now cantilever it. Okay. So the next thing we do now is to insert our beams. Click on beam. And this beam 1. Let's give our beam, let's start with 225 by 450. 450. Okay. The alignment, it's go central, you go middle. And you pick from here, you take it all the way to this point. Give it time. Okay. You can see this is this beam is cantilevered. Yeah, so you can see. And the next one, you take this same one, straight, this one too, it's cantilevered. So I'll take it down to here, let's cantilever here. Okay, this beam is cantilevering. Okay. Take here and join it here. Okay. Now I can have the interior partitions. When creating your beams, you make sure your beams are well arranged. Like now I can have this as my beam 1, have this as my beam 2, then maybe this is beam 3. Okay, you can have this. Move from here. Okay, and have it like this. Okay, and have it here. Take it here. Have it here. The distance between here to here is what? You can have it here. These beams, they go straight to the cantilever because I want my cantilever to have a beam under. So you can choose to make this, the whole of this 1.2 meter, the pure cantilever slab. Or you may choose to have only here or here as a pure cantilever slab, and then maybe here that there is wall, where wall is starting, then you may have something like this, a wall. Just like this. Okay, then I can choose to cross this to here. Okay, have something like this. Okay, the only beam that's left. So let me check the distance. This panel. Make sure your panel, the area of your panel is no more than 30 meters square. Take note of that. Make sure the area of your panel is not more than 30 meters. So we check this panel and we'll see if it's too big, we can split it. If it's not too big, we can read this as a panel. So go to your, okay, and measure from here. Measure to here is 4.48. For control, so you can have a straight line. 5.4. 5.4 multiplied by from here to here. 4 multiplied by, I have to get this. Okay, let me get it from here. This grid, to this grid, so 3,750. So you can say calculator. 3.7 is 3.75 multiplied by 5.4. And see, we'll just have 20. So that means you have take this as a panel, take this as a panel. But if it's more than 30 meters square, then you have to break it based on the BS codes. The area of your bay should not be more than 30 meters square. Okay. So now you can insert your insert your slab. Go to slab. Before you can do your slab, you must first load cases. must be defined before load assignment. Would you like to perform? Then yes. Okay, then you can come to loading generator. Give it time. If you want to have wind, you can take these horizontal load combinations. So you can have your wind tick. In this build, I'm not considering wind. I'm not considering combination for steel. I don't have steel members. So I can just go here and click OK. So we have 6 vertical load cases. Okay. So I'll define my load cases. So, okay, now my slab is here. The thickness of my slab, I'm going to use 150. The concrete cover, I'm going to use 20. Okay, the slab loads, the safe weight, as you select the thickness, it will automatically calculate the safe weight. If I change this thickness to 200, you see the safe weight will also change. See 4.8 or 3 point something. So then I have 150. So the safe weight is calculated the thickness of the slab times the unit weight of concrete will give you the safe weight. This ref is the level you want your, you can leave it at 0. These loads, selecting this thing, there are rooms. You can select rooms and have this, or you can impute value yourself. You can just go and say enter value. You can impute the value whatever you want yourself. Say I want my dead load, and this, remember, this is additional dead load on this. So I'm having like 3.8. Now I come here, life load. This building, what it is for, is a hospital. It's not a domestic, not residential, it's a hospital ward. So we can select this. This is important because if you select residential, the number of persons that will be coming to this hospital is more than just a residential house. So you select the purpose for which the house is going to be used for. So I'm selecting this. Okay. And can now place your slab. Okay. Place your slab like this. Place your slab. Have the whole of this slab. Okay. So now, okay, I can still have. You can have a beam. Let's have here. I'm going to have beam. Alternatively, if I don't want, maybe the whole of here will just be a pure cantilever slab. That will put a wall load. I will put a cantilever load on it. Okay. Down to this place. Okay. And I'm not doing that. Let me just put a beam and then put the wall load on the beam. Beam. You can have a beam here, but let me break. Okay, move from here to here to here. Okay. Let me take this beam as 1. this and pick this beam as 1 to here. Don't break it. Break it will break it to say no. So this beam will not act as 1. You take it up to this beam up here. Let me stop it here. Let me stop the beam here. Okay. If you don't want, you can take this beam to the end. So here, I have it here. Okay, so you can have your beam, you can choose to have your beam like this. Then all these beams will now carry your wall loads. All these cantilevered beams will now carry your wall load. As if you are scared, if you are safety conscious. But what I'm going to do, I will delete all these beams and have a pure cantilever slab, and I will load my slab. On the edge of my slab, it will carry a wall load. So let me do that. So I will just have to delete these beams. Delete this beam. Delete this beam. Okay. Then I have to delete this beam. Delete this beam. I may decide to project this. Project this. Okay. Decide to project this. Okay. Decide to delete this. Decide to delete this. Okay, and then project this, project it, I'll have something like this. Okay, so now I can have, okay, let me project this on too, for rigidity. Have properties, and have here to here. Okay, so now I can pick my slab and insert my slab. Before then, let me offset a line where at the end, this up back on it didn't go to the end, it stopped somewhere here. So you offset this line, offset, just take it to the end here and drop. Okay, so we can measure it from this to this 1375. So now you can pick on your slab, give it property of 150, and still make the cover 20 like before. Okay, and now we can still load it with rooms, or you can say it's balcony, terrace and balcony. Let me just leave it on rooms, and then come to general, select the type of slab. In this case, a cantilever slab, so select type 12, and then it brings this box for you, cantilever, and you enter the cantilever length. From here to here is 1.2, but the thickness of, I want it to just be exactly on this, so you subtract the thickness of your beam, which is 225. So you 225 divided by 2, this calculator, you can say 225, divide this by 2, you have 112.5. Then you subtract it from minus the cantilever. The cantilever from here to here is 1200, so minus 1200, which you have 1087.5. 1087.5. We can type here cantilever length 1087.5. Okay, so a cantilever, you start from the lower, start from here to here and you insert. Okay, you start from here to here and you insert. Okay, so you start from here to here and insert. And you start from here to here and insert. So you can see our cantilever has been inserted, but then we have not put our cantilever loads. So we select on this, edit cantilever, then we put the parapet load. So we can calculate the parapet wall by the calculator. The unit weight of wall is 3.47. Let's assume this, multiplied by the height of this wall going up is 3 meters. 3 meters minus the depth of beam. Depth of the roof beam is 300. So we have 2,700. That is the height. That's 2.7. So I have 9.3. That's my parapet load. So I can 9.3. So either I can copy all the slab at once. Slab, right click, properties, this is okay, cantilever load, additional dead load. Okay, cantilever load is now here, so that means I have to do it one by one. So can just select this and cantilever load, can type 9.3. Okay, I'll update. So you can see the load is here exactly on where the wall was passing. Okay, let's do the same thing here. Can select this, properties, cantilever, 9.3, update. See is here. Select this, properties, cantilever, parapet load, 9.3. 3. This load I'm putting, it represents the wall. This slab is going to carry this wall. That's why I'm putting this load, and the weight of the load, the load that is coming on the slab here is this. Okay. Select this, properties, cantilever, 9.3, update. Can have something like this. So now you also have a wall here, but when you land here, you come within this and enter the door from here for access. So here we create a line load, here, and in this here there is a wall on the slab. We'll create line loads at all these places. Create our line loads. Then let's finish with the slab. Okay, pick a slab. Okay, here you can just put normal slab. Okay, here I can just enclose here with beam. Put this slab, cantilever slab. We can select these properties and from here. Then here the cantilever here is 900. So 900 minus. So the cantilever here is 900. So 900 minus 225. 900 minus the 112.5. 787.5. 787.5. So you can select this properties, cantilever. So here is 7.5. You can update this. You can see now it has fallen in place. Okay, so this is how you now input it. And then here you can put a line load. Let's put a line load here. To do that, just go to loading, come to points, line and area. Click here. Okay, and look at this slab. These loads are on slabs, so you can pick line. So what is the magnitude? Is 9.8. To start and end is 9.3. So both the starting and the ending is the same. Sometimes if you want your starting your load to be bigger and the ending should be smaller, you can alternate in these boxes. So you can have it from here to here. Okay, so here too is carrying the load. So now the load is here. And I have one on the slab. I have it here. Okay. Not necessarily be exact. I have it here. Okay. I have the load here. Okay. I have the wall load here. Yeah. So this is how you assign your wall load on a slab. There is a partition wall that is starting on the slab here, so you must define it. software will know. So let's go to 3D to see what it looks. This is what you have. This is exactly what you have, and this is exactly what we want. Okay, so forget a beam. You will put this beam. Go to plan. So we copy this beam. Properties from here to here. So this is what we have. You can see this is the wall load it's carrying. You climb here, you enter, you land here, then you enter. Okay, there's another wall here. There's another wall passing here where there's a door. So let's also put both loadings, point and area loads, and then pick this and then type descend 9.8, 9.3. Okay, then have it here to here. Yeah, so you can now look at it.